that transaction you've sent to me, you are trying to like send from yourself to yourself, or what is actually happening there? Because there is like from address to address, and it's like, sorry, and it's like the same address, and then you give it max fee per gas, but you don't give it like amount to send or anything like that.
Which one?
So you sent a link to me today. It was the last link in our discussion on Telegram, and so you have in there like calls. You have there 2 calls. In each you set explicitly max fee per gas, while in the blocks there is like 1 0. How much it would be like?
So the max fee per gas in this transaction is higher than the base fee, so they should succeed. But yeah, there's no value being transmitted. So those transaction based shouldn't do anything.
How much
except
would
increase
be
the nonce?
The default value of like gas that is expected to be transmitted?
21,000 is the smallest amount of gas I think you can send. So that I think that transaction should consume 21,000 gas. But yeah, no value is being transacted, and for that same one, get crashes. So, but I don't know why get crashes to that query.
Because when I look at the logs, it says that it is at index 1, so the first transaction went through, and the second transaction was like out of gas. That's fun.
I think the balance should be high enough for that. But yeah.
What is the calculation, I wonder, for the max gas per block in this case?
It should be I think should be always coming from the previous block. So whatever is the previous block depends on that.
Are you running it on Hive?
That takes well, I'm running that on the Hive as well, but then I usually try to see if the mainnet produces the same issue, and with the mainnet I'm getting the same issue.
All right. All right. And yeah, by the way, I was really wondering what should be the like error code for the cases we don't like expect beforehand. So this can be an example of, say, imagine it's a case of something we didn't knew beforehand would happen. So is there like error code that you would prefer us to use for such cases?
I think there's the internal node error, I think. That something went wrong with the node.
But what if but if we think that something went wrong with the processing of a block, so it's not something wrong with the node, it's something wrong with the request, but we just like haven't investigated that specific case.
Does Sina have ideas on that? I'm not sure how that is handled.
I kind of I missed which case you're talking about.
So on Trello, I think it's last like at the bottom of the Trello found issues. There's gas crashes to invalid nonce, and Nethermind just caches that as an exception, but still it is not to the form.
Right. I mean, crash is definitely not good.
I shared in the chat that yeah, the get crashes that, and the Nethermind production error 0. And I feel that the node should never return error code 0 because we don't have that kind of error code.
Is it this one? Nethermind treats gas 0 weirdly?
No, it's last guess one.
Last guess one. Gas crashes with invalid nonce, right? Okay.
Yeah.
Method handler crashed.
It's not exactly the same as the request for Nethermind, by the way.
There's a couple cases where get crashes, and one is the nonce, and then one is the one I pasted in the chat. There's no nonce error there; it just crashes to that. And I feel that query should succeed, but it crashes on both.
There seems to be just something about validation mode, maybe, or
yeah, if you put validation off, then it succeeds. It's about the validation. The validation makes it fail.
yeah. Yeah, gonna look into it.
But yeah, the Oleg's question was if there's a case that something fails, but we didn't know what it is. I think it should be an internal node error or internal that kind of
But
crash.
what if we really think that it is not an node error, but it's an error of the input? So, for example, input is not valid on the mainnet, or input is just not valid somehow for this like block processing that we are expected to perform.
I think we have invalid input error.
Yeah, but the input is valid. The thing that we like try to do with it is not. So we don't know before we start processing of this block that the input was somehow wrong. And when we started processing of the block, we like find it out, but it's not transaction, not gas, not something like that we've managed to figure out beforehand, but something unexpected happened on processing of that block.
Can you give a more concrete example? Because I think we have error cases for most validation checks. And if the node tries to do something that should work but doesn't, then yeah, I guess it's internal error. For example, when decoding, or I don't know, looking up something from database and
yeah,
it
all right.
failed.
Yeah, that would be good enough. So let's begin today, probably. On our side, we've finished up first review of Lukas, got some stuff to fix, not too much. Began the process of initiation of a review by some other peers on Nethermind side, and we are beginning to do performance check before like being able to merge it in. And we would really want your help, Kilari, on this, because so the idea is, imagine we are doing like 10 or around that concurrent requests to ETH simulate, and each request contains something really performance heavy, performance like encouraging, and we would like to test a few at least cases where we can actually see that nodes perform as expected when, like, say 10 concurrent or 100 concurrent requests come in. And for that we need basically three we devised that we would need something like 3 cases. The one simplest one, it is quite easy to make, just transfers. It is easy, but there are a few hard cases. So first one would be transactions that try to use as much EVM opcodes as possible. So like diverse EVM opcodes, randomized, that are all valid and all somehow like just stressing EVM as hard as possible. And the other one is blocks interconnecting with each other, like information heavily referenced throughout the blocks for all 256 blocks, if possible. So something like that would be really helpful for us to understand the performance characteristics of this method, and if we really need or do not need to lower the like basic amount of gas or amount of blocks that are allowed per this method.
Yeah, that sounds good, except with the diverse opcodes, then I'm not actually sure how I could generate that kind of test cases.
Yeah, that's an issue for us too, sadly.
Yeah, I'm not very familiar with opcodes, and all of my tests are written with Solidity, but I guess with that you would write them in assembly. But I was wondering if you could somehow just generate random bytes, and then you make that kind of test that you try to execute random stuff, and then some of the codes would be invalid and some wouldn't be invalid, but it would still. But yeah, I don't know what is the likelihood that you produce something in a way that is doing something instead of just failing.
Sadly, it will be extremely hard to produce anything valid from like just random stuff. So maybe we can like gather good transactions from the real network and just bundle the contracts in the call data. Sina, you wanted to say something?
Oops, sorry, wrong button. I think that will turn into an EVM benchmark, not necessarily a simulate benchmark. I don't.
Yeah, but the issue is that before simulate, we had no such thing as like possibility of direct EVM benchmarking done in concurrent way onto the single client, because normally you would have your single line of blocks, and even in like anywhere you would test it sequentially. And here we can have concurrent access, concurrent forks, and thus different performance characteristics when data is accessed from the past. Because one could imagine that, say you are on an archive node and somebody is performing a simulate and is accessing some part of the regions from the past, and somebody else is accessing another part of the regions from the past, and your node just gets crushed due to the fact that there are too many random accesses.
I mean, I think it was possible with ETH call as well, if I'm not mistaken.
It, I think, would be much harder, because in ETH call you would just like make one call and that would be it. And if you had, for example, say 8 concurrent threads, each one allowing you to make one concurrent request, it would like end quite quickly. And here, if you would have like 8 long as 200 blocks long ETH simulate calls, your EVM could really struggle. So like in expectancy that every of these calls would take at least 30 seconds.
So my understanding is that ETH will have the same protections against DDoS as ETH call does, meaning there's like a gas limit on how much you can execute before it just stops you. Is that not? Like in ETH call, there's some limit hard coded into the client. I think you can change it via a command line parameter when you start Nethermind, that if you try to execute an ETH call that is bigger than that in the sense that it uses more gas than that number, then it will just hard fail when it reaches that amount. I thought we were going to use that same value for
ETH simulate. Yes, we currently do.
Yeah, so I think both of them, in both cases, a single request can, in theory, consume the same amount of resources, whether it's an ETH call or ETH simulate.
That's true.
We can generate those 256 blocks, and that's probably heavier. And then I was thinking of that with the state overrides. I don't think we have any limit on how many state overrides you can do. And I guess I don't know how much those abuse the node, but I could create a transaction that had huge amount of state overrides. But I would imagine that those are just that you are just setting some value, but those are not actually very heavy to operate.
Yeah, the state overrides generally should just be in memory, I would assume, no disk access. And so worst case scenario, you could consume a huge amount of memory. I think there's also limits on the JSON payload size. I'm guessing that's going to be what ultimately limits how many state overrides you can do. And my guess is the JSON size limit is way lower than any meaningful amount of state overrides. It's like 5 megs or something like that, right?
Yeah, I think we looked into it like a bit earlier. Yeah, there is a limit, and it's around 5 megs.
If you do 5 megabytes of state overrides, is that still fine?
Yes, because the 5 megabytes of JSON is going to turn into much less in terms of just raw data, just due to JSON being not encoded particularly efficiently. And all you can really do is just, again, it's setting in memory. There's no disk access. And so you're going to use, 5 to 50 on the high end is my guess, megs of memory, which is negligible for Ethereum client. I mean, I don't know exactly how much I'm guessing here, but my guess would be somewhere between 1 and 10 times the JSON limit. And I think in the past, for other things, if I remember correctly, JSON deserializing actually is the most expensive part often of these requests. The actual execution is sometimes cheaper, especially when you have these really large requests. And I would not be surprised if that's the case here as well.
So I get you. So basically, as ETH call haven't like any problems, we probably are more or less safe as long as we have similar boundaries and guarantees on its execution. So yeah, but still I would love to have at least a few cases where we would try like to push it, try to see how one would hack ETH simulate.
Yeah, I do think there are some differences. So ETH simulate, in ETH call, you do your call, and then everything is basically just EVM execution, which is very tightly controlled by EVM gas pricing. Like there are people who spend a lot of effort getting EVM gas pricing to be, at least the right order of magnitude. With ETH simulate, there are some things that we're doing that aren't costing any gas. Like generating blocks is functionally free as far as this goes. I do think we have a limit on the upper number of blocks you can have, though. At
yes, we do.
And so I think just having a test to test 256 blocks and make sure that it's not like obscenely resource intensive for some reason might be useful. I don't know how exactly we'd analyze the resource utilization, but just generating the blocks is pretty easy. But that would be, I think, the area that I would, if I was going to do some testing for this performance-wise, I'd look at the block generation because that isn't accounted for in the gas pricing. And I guess transaction, even transaction count is still 21,000 gas per transaction. So it's just the blocks that are free.
I posted a tool from Marius that does this thing where like it generates random looking transactions. It could be used for not for a maybe consistent benchmark that can be reproduced, but just to see maybe find worst cases or something like that. Anyway, I just discovered it recently. I think it's pretty cool.
Is it just
it's mostly used for testing correctness though? Like I don't know if it's been used so much for performance measuring.
And it's just generating like transactions from peer A to peer B, or it is like some EVM upcodes also involved?
Yeah, no, it's EVM upcodes, and it generates, as far as I know, valid EVM bytecode.
Does it require any contracts to be posted before it would be actually usable?
I think it's pretty standalone and self-contained. This was used recently to find bugs in the in DevNet 0 of Prague, and it did manage to find a few.
I'm always terrified when a fuzzer finds bugs because to me it's an indicative of some other deeper problem. Because if you can find bugs via random testing, how many bugs did you miss? Because random testing is notoriously bad at hitting everything.
But humans are also very bad at hitting everything, so...
This is true. Humans are very bad at everything, I agree.
Fuzzers don't get tired.
Yeah, I thought you trust machines more than humans.
I do trust machines. It's just this particular machine is basically doing a random walk of a search space that is nearly infinitely big. And if you can find bugs by randomly searching an infinitely large space, then it means there's a lot of bugs out there. And that's what's terrifying.
But it's not usually not uniformly random. So usually you are at that kind of edge cases there, like 0, for example, is that kind of edge case, or -1 or +1, or that kind of like thing. And like it's generating also valid opcode, so it's removing those non-valid opcodes. So you kind of like try to make it to generate that kind of meaningful stuff as possible.
So I'm a huge fan of parameterized testing, which it sounds like what you're describing, where you basically define a human looks at the code and says, here are the edge numbers. test the combinatorial set of all the edge cases together in various combinations. That is super useful in my opinion, for the exact reason you described. Fuzzing historically, though, has just meant randomly throwing stuff at the wall until something breaks. Now, maybe what they're doing is actually parameterized testing. They just call it fuzzing because fuzzing's funner to say. I don't know.
Well, fuzzing includes that you add some randomness to it, and I guess you are just saying that you would brute force through all the kind of combinations that you are given.
Yeah, like I mean, if you're doing edge cases, you can usually narrow the set down to something that is searchable within finite time, finite human time. So it might take like a day or two to run, so it takes a long time, but you can usually get the combinatorial set down pretty low. It's once you introduce that randomness that I start getting scared, because like I said, if the search space is so big that you need randomness in order to even start to search it, then it means that if you hit something, that's terrifying, because you've hit something in a search space that's so big that you couldn't actually search it in a reasonable amount of time.
Corner case combinations are a mess always. It is extremely hard for a human to see all the combinations of corner cases. So if you even would have 3, it would be too difficult to cover them all. Human.
Right, and so like I said, I'm a big fan of the human goes through and defines, here's a corner case, here's a corner case, here's a corner case, here's a corner case. And then you set up a program that will test, okay, corner case A without corner case B or C, corner case A with corner case B, corner case A with corner case C, corner case A with B and C, corner case B with C, etc., like the whole combinatorial set. And it takes a very long time to run, but it covers the entire search space. It's only when you start randomizing that you cannot cover the search space in finite time, and you do not have enough insight to choose which space to search. And if you find something, it means you're finding something in a massive search space. And if you hit something in a massive search space that should never happen, it's basically a guarantee that there's a lot more that you missed that you didn't hit.
Well, with each simulator, I'm sure that there's a lot of cases that I have missed and I haven't thought of. And I think it would be useful to have fuzzer running and comparing get and Nethermind to each other. I'm quite confident that the fuzzer would find stuff there. Because well, at least I'm smart enough to figure out all the edge cases that to think of to test. But Mike, if you want to volunteer in thinking of all the edge cases, then I would appreciate that.
It's usually just, test 0, test -1, test +1, test uint max, test uint minus max. Like, and then if you've got conditionals that are on some borderline, test those numbers as well. Like test max gas -1, max gas +1, max gas exact. Like you just basically go through and define all of those, and then you set up a parameterized test that just does the combination, like combinations of all of those things. And that is super useful. I'm a huge fan of that type of testing. I think it's one of the best kinds of testing that you can do.
It's just if you just do it, then I'm fan of that.
There was a C# tool a long time back that I really wish Microsoft continued working on that actually did this for you. And so you would give it your code, and then it would go through and find all of the boundary conditions, and then it would automatically generate tests that hit all those boundary conditions, and automatically generate tests that were combinations of various boundary conditions being hit. And it's essentially generated code that would ensure that every possible code path in your code base was reached. It was very cool. I don't know why they dropped it. It was incredibly useful. It's just a prototype, unfortunately.
Was this Ethereum related or something else?
No, this was like, I don't know, 10 years ago, 15 years ago, from Microsoft Research. Something called HES or something like that. I forget what it's called.
Come again, how it was called?
Let me see if I can find it.
In the Ethereum Foundation, would it be possible to use some resources that could do fast testing on the each simulate, or is that something that we have to do or nobody else does it?
I think there's few people who do fuzzing. I'd have to ask around and see. Maybe I can get some help to at least set up the process, and then we can take it and run with it.
Yeah, if someone can set all those things up, and I hate setting things up, but if somebody can set them up, then I can also fiddle up with it and try to think of inputs and that kind of things that could be needed to be tested. And now when we have Nethermind and Get, then it would be kind of easy to do in a way that we can just compare those inputs to each other, and then if they find some differences, then we can check those, see what's going wrong. But still, there's no difference between Get and Nethermind, so I don't think we would benefit from the fast testing that much yet. But
Yeah.
after we get all those, after we have those human tests all matching, then we benefit from it.
Yes, first take the low-hanging fruit, and then. But I think it would be interesting because if we have a tool that works for Assimilate, then it probably would very easily work for other methods as well.
Basically, we want something that would generate random blocks, and then if it generates random blocks, then we could convert those to each simulate calls and then run those. And I would guess that kind of tool could be something that exists already. I don't know if that TX-fuzzing is doing that kind of stuff.
No, TX-fuzz not. I don't know.
TX-fuzz is just generating one transaction, not multiple ones.
Yeah, I mean multiple, like a lot of them, but not sequential transactions. So they're kind of independent of each other.
But yeah, I guess we could use it to generate 100 transactions, and then we make a block out of them. Or multiple blocks, and then we run those and compare the results.
I think the devil will be in the other parameters as well, like not only the transactions, but like all the override fields and everything.
Yeah, but for those we can also generate some random stuff. Well, maybe not for something that doesn't make sense to generate random stuff, but somewhat random stuff we can generate on those.
Mm-hmm.
Do we have anything else?
I don't have much. Didn't end up doing a lot last week, but in one of the discussions, I don't know if I mentioned this, but in one of the discussions, something interesting came up. Basically, it seems like either 3074 or 7702 for account abstraction are likely candidates for Prague. And given that one of their main features is batch transactions, I think Assimilate can play an interesting role in testing those methods. Well, if Mike asked if they brought it back, I think 3074 is probably like there was a lot of community pushback against it.
Sorry, I was referring to what Oleg pasted.
Oh,
not what you were saying. Sorry.
So yeah, I think Assimilate can be possibly interesting. Like the intersection of Assimilate and account abstraction, I think there's room to explore there.
Yeah, I see that's right away. It should be useful and used there. When you are making batches, you should simulate them first and then send it. But do those add something that we need to add to it simulate? Is there some features that are missing from us?
I think the only requirement is being able to simulate from a contract address, and we can do that already. So I think that's all that's really needed.
And the batches are actually multi-calls, I guess, and not multiple transactions.
So 430, are you talking about 43074?
Whatever is getting included, I guess that's one it is.
So either way, so whether it's 3074 or 70, whatever the latest version is, essentially they all allow an EOA to execute code. And if an EOA can execute code, then it means an EOA can execute a series of things. So like execute an approval followed by a swap on Uniswap as a simple example, right? And so you could use something like ETHSimulate to simulate a series of actions using using some tool like Interceptor, for example. And then those would get batched up into or compiled into a call to some sort of multi-call contract that is executed from the point of view of the EOA. So the EOA is the message sender, but you're executing a series of things. And so there's an interplay there in the sense that you can use ETHSimulate to prepare the transactions you want to do. And then once they're all prepared, then you could use an invoker for 3074 or custom code for the other one in order to actually execute that on-chain atomically. Either of them would be super useful for us, assuming people start using invokers.
Yeah. Was there some discussion that you were mentioning ETHSimulate, Sina, about those?
Yeah, well, basically, I was bringing up ETHSimulate as something that people should implement, and someone mentioned that like this interplay between 3074 and ETHSimulate. So basically, they were saying, yeah, ETHSimulate will be very useful for testing, and it's like basically simulating this batch of transactions. So when we have account abstraction, then sorry, I need to go to the door.
Hey guys, sorry for being late.
It's okay.
But I guess that load testing is something that should be done. I don't know how much heavier ETH multicall is or ETHSimulate is compared to ETH call, for example. That's probably something that should be done for both Get and Nethermind.
So for testing, there are two things. One, we need to make sure that the timeouts work well, right? And there are two ways of timeout, I think, at least for Nethermind. There's a just timeout, and there's gas timeout, let's say, like gas depleted, right? And that it covers across blocks. And the second one is that the actual mechanism of ETHSimulate itself should be fairly light, but we need to confirm it, right? That when we do an amount of blocks, that this itself is not heavy.
Right, because the blocks are the main piece that's not accounted for with gas accounting, right?
Yes.
Is it heavier to reference that kind of block that is in the currently in the generated by ETHSimulate, or is it heavier to kind of reference block that is kind of in the 256 blocks, or should that be the same? Like if I create 100 blocks and then I refer all those generated 100 blocks, is that heavier than just try to look up the blocks like which already happened in the blockchain? I guess it would be somewhat same.
To be honest, I didn't understand that.
I think the question is it more expensive to work with simulated blocks in memory versus blocks that are actually part of the blockchain? And I think the answer is, unless the block happens to be in memory already, it's almost certainly more expensive to go to disk to get it than deal with simulated blocks in memory.
Yes.
Aren't all those blocks in the not in memory, or they are all those 256 that ETHSimulate can access, those are probably in the memory already?
Yes, they should be.
Yeah, so I would imagine it would be the same, that there shouldn't be really difference.
For access, for building off of blocks, I think you're correct. So the same as ETH call. ETH call can be derived from can build off of any block in history that the node has access to. And so that part will be the same for ETH-Simulate. The potential issue, which I agree with Lucas is unlikely, but worth verifying, is that if you simulate 256 blocks, then it means the node has to, generate 256 blocks in memory. And, the node wasn't necessarily designed with the idea in mind of having lots of blocks being spawned at the same time. And so maybe there's some performance degradation there.
I would more say about preserving state within those blocks, between those blocks, etc. Right, because it's all in memory temporary. So, for example, just making sure that we don't blow memory somewhere too much.
Sure. My guess is probably not. I can't really think of anything that the EVM gas accounting wouldn't already account for that you could blow up.
Yes, I do agree that
but it's worth
just a safety
caution.
check.
Yeah.
Well, there's this. We can generate 256 different states of the blockchain. I guess those are going to be different.
Yeah, so just generate 256 blocks. Each one maybe do some state changes, and each one do some contract calls that mutate state. Just the kind of normal operations that each do a little bit of work, and then I don't think it needs to be a super complicated test. We just want to kind of verify that at the edge it doesn't cause problems. If I'm understanding Oleg and Lucas correctly.
Yeah, just a sanity check that it doesn't blow up in any in any suspicious way.
How should we go with this? I can do some of the tests like this, but then I don't know how we should be running those. Like I don't want to add this kind of test to the test suite in a way, because then it just takes longer time to process.
So I think my recommendation would be we generate a test that just is big, so to speak, where big means it actually simulates 256 blocks. Each block has some state changes and so state overrides and some contract overrides and some contract calls of those overridden contracts with overridden state. And then just like one test like that. And then Lucas, Oleg, and Sina or whoever else can then just run that test manually. Like maybe it can be marked as skip or something. I don't know how the test framework works, but mark it as skip. And then someone on a dev team can just run that manually and just kind of monitor performance metrics externally as it's executing.
I guess that need to be run many times and multiple concurrent requests to kind of like really overload the node, unless you want to analyze if that something in that transaction takes longer than should be.
I don't think we'd need concurrency. Like I said before, I think the concurrency issue is should be the same as ETH call. I don't know, do you guys disagree? Do you think that if there's a problem, it may only be noticed if you do 10,000 simulates simultaneously? Or would you notice the problem if there's just one?
So generally we rate limit how many heavy state access calls can be done in parallel, and we queue them. So there's a limit for that.
Okay.
So
if you want to hit the timeout, then you need to somehow make it loaded the node so that it couldn't process those in time.
So those in queue can also timeout, right? So not sure.
Oh, okay. But yeah, then you should add huge amount of things to the queue so to get the timeouts, I guess.
It should be easy enough, right? You just copy and paste 100 times the request.
Yeah, but then you also need to monitor the node and do that kind of stuff.
Yeah, so I would leave the actual monitoring side. I would leave that to Oleg and Sina. I don't think we have the expertise or skills to even know what to look for. But I think we can at least generate the test data. So the big ETH simulate payload that kind of maxes out as much as we can in one simulate call. Like I said, I think the critical things are lots of blocks, so all 256 blocks, state overrides, contract overrides, and then transactions that actually call those overridden contracts. And each block maybe is also full, like up full enough that we can almost reach the default node gas limit for the system-wide gas limit.
100 probably, right? Megagas, or I don't know if it's for gas it's different.
Is it 100 million for the?
It's for
system
Nevermind, it's
limit?
100 million.
Okay. So yeah, so basically 100 million gas worth of transactions spread out across 256 blocks. Each transaction touches code that maybe a mix, or half the transactions touch code that was provided via an override, and half the transactions touch code that was not overridden. So we get a good mix of data there. Some of it's going to disk, etc.
Okay, yeah.
Does that sound reasonable to everybody? And then once we get it, once we generate the test data, Oleg, you can run it in Nethermind and monitor performance however you guys do that. That's great.
Do you have anything else?
Nothing from me.
All right. Thank you all for coming. And
Thank you.
See you next week.
Thank you. Bye.
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 Bye.